Good morning. Welcome to day 1 of From Coder to Conductor, a 5-day series on AI-orchestrated development. Today, we lay the foundations. 2 hours, watch the demo. By the end, you'll know how the major AI coding tools differ, how the models actually work under the hood, and how to write prompts that ship code instead of approximate code. Days 1 through 4 are 2-hour teaching sessions. Day 5 is hands-on. You'll build something with a teammate using everything you learned. The same recipe and meal planner runs through all 4 teaching days. By day 4, it's a tested, secured, deployable mini app. 5 pillars, 1 mindset. We'll spend roughly 20 minutes on each. AI landscape, LLM internals, prompt engineering, reasoning, and repo mapping. The mindset connecting all 5. You're not writing code, you're directing AI to write code. This is the most important slide of the day. Language is the new compilation layer. That's the mental shift. 5 years ago, you wrote source code and the compiler turned it into machine code. Today, you write intent in plain English, and the language model turns it into source code. Your job is no longer to write every line. It's to spec, decompose, and verify. Look at the right side. Intent. What are we trying to do? Spec. What does done look like? Code. How do we build it? The agent does more and more of this part. Verify. How do we know it works? The 4 pieces are still there. Just where you spend your time has shifted. Pillar 1. The AI landscape. Single tools, multi-agent systems, same job? Yesterday. Autocomplete. You held the picture in your head. AI offered local suggestions. You tabbed to accept. AI was faster typing. Today, orchestration. The agent reads the codebase, drafts plans, writes code, runs tests. You spec, the agent ships. You verify. AI is a junior teammate you direct. 5 tools: Claude Code, Anti-Gravity, Cursor, GitHub Copilot, and Kiro. They're all built on the same family of frontier language models: Claude, GPT, Gemini, depending on configuration. The difference is in what each tool wraps around the model, how it loads context, runs sub-agents, applies edits, and lets you review work before it lands. Pillar 2. 3 things every junior should know. Tokens, embeddings, context windows. That's it. Tokens. The smallest unit a language model sees. Not letters, not whole words, fragments. Look at this sentence. The planner uses MySQL for recipes. That's about 10 tokens. Notice planner splits into plan and ner, and MySQL splits into MySQL. Pricing is per token. Latency is per token. Context limits are per token. Rule of thumb: 1 token is about 4 characters of English, or 3/4 of a word. Code averages 1 token per 3 characters. So when someone says, "We have a 1,000,000 token context window," they mean roughly 750,000 words of working memory. Embeddings. This is the magic behind every @codebase feature you'll use. Words, sentences, and code blocks become vectors, typically 768 to 3,000 numbers per item. Things that mean similar things land geometrically close. Look at the plot. Dietary terms cluster together. Calorie terms cluster. Test terms cluster. Database terms cluster. The model doesn't grep your repo when you ask a question. It embeds your question, then retrieves the closest chunks of code by meaning. Practical example. Ask, where do we validate dietary restrictions? The tool returns dietaryruleevaluator.cs, even though that file never says the word validate. Why? Because evaluate and validate are geometrically close. Context window. The model's working memory for a single conversation. Sonnet 4.6, around 1 million tokens. Opus 4.6, similar. Haiku 4.5, 200,000. Local models on Ollama, varies. Bigger isn't always better. Cost and latency rise with input size, and accuracy can drop in the middle of very long inputs. Pillar 3. Prompt engineering. Plain English is your compiler now, so treat prompts the way you treat code: structured, reviewed, versioned. 0. Few or many examples. 3 modes. 0 shot, just the task. Use it for generic things, extracting recipes, formatting JSON. Few shot, task plus 2 to 5 worked examples. Use when you need a strict custom format. Many shot, 20 to 50 examples. Use when the domain language is unusual or edge cases matter. Role, context, task, format. 4 parts. Always in this order. Even sloppy prompts get sharper when you label them. Role. Who is the model right now? You are a senior .NET 8 engineer. Context. What does it need to know? We use MySQL, repository pattern, named migrations. Task. What single thing must it do? Add a recipe entity with dietary tags and a migration. Format. Exactly how do I want output? Reply as a unified diff against /API. No pros. Same task. Explain the constraint engine in the meal planner repo and cite the files. 5 tools, 5 invocations. Identical concept. Watch. Pillar 4. Reasoning. Let it think out loud. Chain of thought, controlled logic, and when not to bother. Chain of thought is the cheapest accuracy upgrade you'll find. Look at this comparison. Naive prompt. Plan a 7-day vegan menu under 1,800 kilocalories per day. No repeats, $40 budget. Often returns a plausible-looking menu with repeated meals and $58 cost. Wrong answer, confidently delivered. COT version. Same task, but with explicit numbered steps. List candidate recipes. Compute kilocalories and cost. Reject duplicates. Reject anything blowing the cap. Then return JSON. Result. 7 unique meals, $38.40 total, all under cap. Same model, same temperature, dramatically different output. Reasoning isn't free. Tokens go up, cost goes up. Here's the decision tree. Direct, 90% of calls. Lookup, formatting, summary, cheapest. Chain of thought. Multi-step logic, math, constraints. Plus 30 to 50% tokens. Big accuracy win. Self-consistency. Critical answers, eval-driven runs. 3 to 5 times the cost. Sample n times, take majority. Tree of thoughts. Open-ended search, optimization. 10 times or more. Save it for the day 4 capstone. Pillar 5. Context engineering and repo mapping. Help the agent see your codebase. The agent only knows what you tell it. Treat context as scarce real estate. 2 columns. Bad. Dump everything in. README, schema, vendor folders, lock files, node_modules. The agent loses signal in noise. Good. Curate. Claude.md, the domain folder, the constraints folder, the relevant tests, plus whatever you mention. Every tool has a memory file. 5 conventions, same idea. Claude code reads Claude.md. Anti-gravity reads workspace rules. Cursor reads ..cursor rules. Copilot reads .github/copilot-instructions.md. Kiro reads the .kiro/steering folder. Product, tech, and structure.md. All 5 are plain text. Commit them. Update them in PRS. Review them quarterly. They're how an AI tool learns your project's conventions without you having to repeat yourself in every prompt. Final demo. Watch Claude code drop into the meal planner repo cold. Step 1. Enter. Agent reads Claude.md on its own. Step 2. Map. Embedding scan produces a module diagram. Step 3. Ask, where do dietary rules live? Returns files plus function names plus line numbers, all cited. Step 4. Plan first. Agent writes a plan. We review, approve, then it ships the diff.